This is module for investigation 9, solving exponential and then logarithmic equations. Okay, so I want to show you how to do this. So number one, solve each of the following equations for x. Find the exact answer and then use your calculator to approximate the answer to nearest thousand, which is 3 decimal places. So when you have okay, so let me actually show it to you as one of the lessons. So when you have exponential equations, okay, there are two cases. If b to the x equal to b to the y, and then since the base is the same as b each other, so you can just say x equal to y. So for the example, we have let's say we have 2 to the x power, and the other number is 32. And then I can say that the 32 as a 2 to the fifth, so x must be equal to 5. So very easy to solve, right? But the problem is case 2. What if you have a different base? And then you cannot say that the x equal to y because b is not same as a. So what you do is we use the log on both sides to solving as a logarithmic equation. So if you put the log on both sides, and then you can use a power rule for the logarithm as x log of b, which equal to, you can also say y pulled out 2 if you want, but I just solving for x anyway. And then you can divide by log of b both sides. And then that's all. So this is the answer for the x. So as an example, if you have a 2 to the x equal to the 5, there's no way we can say 2 equal to 5, right? So in this case, you put the log on both sides. But you can choose any log you can, okay? You can use a log of 10, log of e, log of any b, except the b is not equal to 1 or negative. And then you can put out as x of the log of 2 equal to log of 5, and divide by log of 2 both sides. And then this is the exact answer, and then you can approximate it. So log of 5 divided by log of 2, which is 2.322 as approximations. Okay, so that's what we're going to do in the problem we have here. So which is 4.9. All right, so number one, since the base 4 and 3 is not the same, so you can use a log on both sides. Log of 4 equal to log of 3 to the x power, which is log of 4, but you can put the x as a factor of the log of 3, and then divide by log of 3 both sides. And then you get the x equal to log of 4 over log of 3, which is, this is the exact solution. And then if you use a calculator to approximate this, it becomes 1.262. Alright, as a b. In the b, which is 17.5 is not a base, so base of the x power, right? So you gotta divide it. And that cancels out. So you got 22.4 over 17.5, which equal to 3.4 to the x power. And then you can put the log, but this time I want to put the ln. So ln of 22.4 over 17.5, ln of 3.4 to the x power. Now you have ln 22.4 over 17.5. Now you got x of ln of 3.4. And then divide by ln 3.4 both sides. And then you get the x equal to, because this cancels out, ln of 22.4 over 17.5, which is go together, okay, over ln 3.4. So this is the exact solution, okay? And then this is approximately 0.202. Okay, so the number 2 I already explained it, okay? So if a equal to b, which means you can say that as, you can put any base, the user base 2 this time. A must be same as this, okay? Yeah, that's what they're saying, which means you won't change any of the value, okay? So since a is equal to b, so when you take the log on both sides, it will stay the same base, same values. And also what they're saying in the C is we cannot actually put the value cannot be negative here. So it's not possible to take the logarithm or of 0 or negative number, because when you take the log, 0 is undefined, and then log of any negative number is also undefined case. Okay, because when you have a log with a base of x in here, that in order to find the value of this, x must be always positive number. Okay, that's important. Alrighty, let me talk about the number 6. Okay, in number 6, they're talking about the two city population of the two cities. So in 1990, the population of Diamond Bar was 45,000, and population of Chino Hill was 37,000. In 1992, the population of Diamond Bar was 51,750, and the population of Chino Hill was 44,400. Assuming that both cities' population grow at an exponential rate, how many years will it take for the population of the Chino Hill to surpass the population of Diamond Bar? So first of all, we have to actually figure out the growth rate. So since from the 1990 to go to 1992, so 2 years passed. So I want to use as the 2 year. Well, let me do the separately first, okay? So let me use as a Diamond Bar. Okay, so Diamond Bar 2 year growth factor, because it's increasing. So growth factor will be the from the it was a 45,000 becomes 51,750 divided by 45,000. Then I get the 1.15. Okay, and then the nicely have is a 1 year growth factor. Okay, so 1 year growth factor will be from the 1.15, and then it's been a 2 year growth factor, so put 1 on the top, and then you get the 1.072324 actually, but then I'll take only this one. Okay, so that's the 1 year growth factor, so I like to use this one. For the Chino Hill, so 2 year growth factor will be the 44,400 divided by 37,000, which is 1.2. So now if you change the 1 year growth factor, then it will be the 1.2 to the 1/2 power, and that becomes 1.095. Okay, now we are looking for the years. Okay, how many years take it for the population of Chino Hill surpass the population of the Diamond Bar, right? So I can make the equation. So the Diamond Bar equation I want to call the P is, so initial value was, which is starting from the 45,000, and then I'm using the 1 year growth factor 1.072 to the 10th power. So now you can find for any years. And for the Chino Hills, I'm using the Q for that. So Q is starting from the 37,000, and then the 1 year growth factor is 1.095 to the 10th power. But we are looking for the actually the when's gonna be the population of the two cities gonna be same. So what I do was I want to say P equal to Q, and then 45,000 1.072 T is equal to 37,000 1.095 T is equal to, okay. So I'm divided by 37,000 both sides and divide by 1.072 T both sides, T's power. And then this cancels out and this cancels out. So I got 45,000 over 37,000 equal to, and then I'm using the power of the quotient rule, which is x over y to the n power, same as x to n power over y to the n power. So what I'd say is I can put the 1.095 over 1.075 as a tth power. Now t's becomes exponents, so solving for that is also you can solve this way too. You can take the log on both sides, or you can change the exponential the logarithmic equation. So t equal to the log. So base is 1.05 over 1.075, and then of the 45,000 over 37,000. So when you compute that, you're gonna get 9.2 years. So it takes the 9.2 years to surpass, which is from 1992 plus 9.2. So it will, after the 1999, and then the Chino Hill population will surpass the Diamond Bar population, right? Okay, number 7. In the 1935, Charles Richter, a seismologist at the California Institute of Technology, invented the method for the comparing the magnitude of the earthquake. Since the amplitude of the seismic waves, seismic waves of the different earthquakes can be over 1,000,000 times as large as the waves as small earthquakes. Richter developed a special scale now called the Richter scale for the measuring the magnitude of these earthquake waves. This formula or function takes the input amplitude of the seismic waves of earthquake and output what we call the magnitude of the earthquake. The magnitude is Richter's scale rating of the strength of the earthquake, and this number is reported in media. The magnitude M is an earthquake whose seismic wave amplitude of A is defined to be, and this is a formula. So this is a formula. So magnitude is always equal to log base of 10 of A over A sub 0, and the A sub 0 represents the amplitude of the seismic waves of the standard earthquake, whose amplitude is 1 micron, which is a 10 to the negative 4 power centimeter. So describe the meaning of the ratio A over A sub 0, which means this is about the ratio of the amplitude of the seismic waves for two earthquakes. And then describe the effect of the inputting the A over A sub 0 into the log of 10 function and what the value of the M represents. Which means if you put it in the M of the log base 10 of A over A sub 0, which is you can do as log of base 10 of A subtracting the log of base 10 to the A sub 0, okay? So you can make the difference of the two logs, which is magnitude, as you can compare with the amplitude, the seismic waves for the two earthquakes. Okay, and then the next one, let M1 and M2 represent the magnitude of the two earthquakes whose seismic waves are the amplitude of A1 and A2 respectively. Use the formula to given above the property of the logarithm to define the simplified formula for the difference m2 minus m1 in terms of the a1 and a2. So I want to find out the difference between the two amplitude of the m2 subtract the m1, which is I can use as a base 10 of, instead of the a, put the a2 over a sub 0, subtracting the 10 of, base 10 of a sub 1 over a sub 0. And then now two logs, I can make the one log because it's a difference become quotient. So I can make that as a2 over a0 over a1 over a0. Then if I simplify that, it will becomes a2 over a1. Okay, so that's what they have here. And then we're going to apply to the real problem in C. So in C, on the May 22nd, 1960, 9.5 magnitude earthquake struck near the Valdivia, Chile. On the November 1st, 2015, 1.1 magnitude earthquake struck Phoenix, Arizona. How many times as large were the seismic waves of the Chile earthquake compared to the Arizona earthquake? So what I do is, okay, I'm gonna do the m2 minus m1, which is a log with the base 10. What am I doing here? Base 10 of a2 over a sub 1. So one of the earthquake was magnitude was a 9.5, and the other one is 4.1, which is a log base 10 of a2 over a1. 9.5 minus 4.1 is 5.4, with the log base 10 of a2 over a1, and then change the exponential function base 10 powers of 5.4 equal to the a2 over a1. And then solving for a2, multiply a1 both sides, and then a2 now become 10 to the 5.4 to the a1. But if you figure out the 10 to the 5.4th power, it's going to be the 251,189 times a1. So which means the earthquake in the Chile was 251,189 times stronger than the earthquake in the Arizona Phoenix at the time. Write a formula that determines the amplitude of the seismic waves of the earthquake in terms of magnitude of the earthquake. So since we have magnitude is log base of 10 of a over a0, so if you actually putting as an exponential form, 10 to the n power is a over a sub 0, and solving for the a, multiply a sub 0 both sides, and cancel, so a becomes the 10 to the m times a sub 0. So this is you can use as a formula to find out the amplitude. Alright, that'll be all for the investigation 9. Thank you for listening.